Okay, so for all planets or satellites describing circular orbit. Now, writing this statement has no, uh, credit, but it's good that you write about this. About the same central body. Now, number one, what you're going to do is you're going to say the square of period t is proportional to number two, the cube of radius r of the orbit. Now, obviously, you can write this as one single definition, but I just wanted to clear it out that this holds 1 mark and the other one holds the second mark. Okay. Now, the derivation of Kepler's law is one of the most asked questions.
Sir, did you write for all planets or satellites describing circular orbit?
Yes. All right. Now, so for Kepler's law, they're going to give you a lot of derivations, and from the paper, I'm just going to tell you this. So first of all, they say show for the planet in a circular orbit R, the period t of the orbit is given by the expression t squared equals to CR cubed, where C is a constant, and explain your working. So how you go about this? You guys have written that, right? Should I move forward now?
Yes, sir.
Okay. So what you're going to do is the very first step you're going to take is you're going to say, okay, you were copying. I'm sorry. So you say that the centripetal force, which basically makes something go in a circular orbit that we did in the first chapter, is provided by the gravitational force. All right. So this is basically the main principle. So the centripetal force is given by mr omega squared, and the gravitational force is given by gmm over r squared, right? Now, the small m's just cancel out, and then you get, you can multiply r over this. So you get r cube omega square equals to gm. All right, is that clear up till here? Okay, now, the next thing you're going to do is you should understand that since omega is 2 pi over t, so we can replace this omega from that, which means from this point onwards, we can write r cube equals to 2 pi over t whole squared equals to gm, like that, which lead us to r cube times 4 pi square over t square equals to gm. Now, just make one of these, like you want to make t squared the subjective equation, which means that then you can write it as t squared equals to 4 pi square over gm times r cube. If you really look at this part of the equation, which is right here, you might see that 4 is a constant, pi is a constant, the gravitational field, the gravitation constant is capital G, and m is also the mass of the planet, that, the central body, which is also the constant. So which means then we can write that C is the constant that is equal to 4 pi squared over gm, And hence we can state that t squared equals to c times r cubed. And that's how we have proved it. Is that clear, everyone? Fahar, Anusha, Abdul Mois,
Yes, sir.
Nadia,
Yes.
Ahmed, Musa. Okay, good, very nice. All right, now, speaking of this then, okay, in the next sort of question, it says, show that the radius x of a geostationary orbit is given by the expression gr squared equals to x cubed omega squared, which is the acceleration of free fall of Earth. And obviously, omega is the angular speed of satellite about the center of Earth. All right. You can write this down, then we'll move to the next question. How come this question has gone underneath this? For some reason, all these questions are gone underneath them. All right, probably I made some mistake. It's all right. We just need to do this anyway. Okay. There is some kind of issue. Okay, now, so again, in the second derivation, which is this one, the moment you should see like x cube and omega square, you should always remember Kepler's law, because that's how it's related to, right? So what you're going to do now, as you can see, that the same thing, if this is the Earth and that's the satellite that we're looking at, so obviously this distance is, they say it is x, and it's going as circular motion, which means that the force of gravity is providing the centripetal force so that it can move in a circular orbit, right? Again, the same thing, force of gravity equals to the centripetal force. We're going to write this as gm, and the distance between them is x squared, because gm m over r squared, and this will be m, and r is x, so omega squared. So only thing that is changed now is that they have given x instead of r. Really, you can call anything the radius, so it's not a big deal. M and m will cancel out, so it's going to be gm over x squared equals to x omega squared, like that. Okay. Now, if you look at this, this will cause it to be gm equals to x cubed omega squared. Now, this part is done, but right now the main issue is that here we do not have the same expression, because it says g is the acceleration of free falling Earth surface, and g is given by gm over r squared, as you guys already know. Okay. If we consider that the radius of Earth is r, then we can write g to be gm over r, capital R squared. So can I say gm is equal to gr squared? Would you guys mind if I do that? So then what I can do is I can replace this gm with this gm, and then I get g r squared equals to x cubed omega squared, and that's what I needed to prove. Okay, have a look at it and let me know if you don't understand this.
Sir, could you repeat the thing you did to get gr square? The very
Yes.
last step you just did.
Yes, I'll do that. So if you look at the Earth, right? So Earth is like this. And this is the center of Earth, which means that the radius of Earth is r, because they've said in the question that r is the radius of Earth. So the issue is that the other question, I cut it off, so I'm sorry about that, but this is the radius of Earth. If I want to find g at the surface, So the gravitational field strength has a formula of gm upon r squared. You remember this?
Yes, sir.
So at surface, can I say it's going to be g equals to gm over r squared? Because that's the radius, right? So then
Yeah.
gm can be written as g times r squared, right? If you see, this section of the equation and this section of the equation are the same. Both are actually the mass of Earth and the universal gravitation constant. So can I replace them? So basically, I've just replaced gm to be gr squared. That's how I got the other part of the equation. Understood?
Yeah. Yeah.
Okay. Is there somebody who did not understand this? Mokshe and Gatika?
No, sir, I understood.
Okay.
Got it, sir.
Very good. Very good. All right. Now, I hope you guys have written this as well. Now, the reason I'm doing, I'm just trying to do all the kinds of derivation they are going to give you related to Kepler's law. So if you go through all of them, there is no chance you're going to get the answers wrong or you don't, do the derivation. So sometimes, now, if you see this question, right, how do I know this is related to Kepler's law? Because I see two things. Because I know that t squared is proportional to r cubed in Kepler's law. That's what the law is. And I see both the things right here. You guys see? So it means Kepler's law. The moment you see that there is a relationship here, you should remember that the centripetal force should be equal to the gravitational force. Understood? Again, centripetal force is mr omega squared and gravitational force, because it's saying that r is the radius of Earth orbit of the sun. So we're going to just change this r to capital because they've just used this symbol. And then this will be g m over r squared. I'm just going to cancel out this one. And I'm going to cancel out this one. So what I get is, I get r cube omega square equals to gm. Now, what do I need? I need m to be the subject, and there is a omega. So I know omega is 2 pi over t. I'm going to say r cube 2 pi over t whole square equals to gm. This is going to turn it into 4 pi square over t square equals to gm. And now I just need to make m the subject of the equation. So I'm going to make it as m. I'm going to take t there. G there. So it's going to be 4 pi squared r cube over gt squared. And now I've proved that. Okay. So the basic idea is that no matter what question comes in Kepler's law, if you remember that you need to equate the centripetal force to the gravitational force, you will end up getting the same answer every time, whatever they've given, right? Is that clear?
Sir, the question right before this is actually part one of that one, and the thing on top is part two, isn't it?
No. And that is
This
from
one
a
is
different, yeah,
it's from a
that's a
different one?
yeah.
Okay.
That is from a different paper. That is from 2009. This is from 2013. Basically, probably when I was cutting them, so I did not cut it completely. So that's why the issue is there. Okay. Usually I don't do that, but my bad. All right, but the thing is that I want you to focus on the derivation right now because a lot of different derivations are going to be in your exam. Okay. Is that clear?
Yes, sir.
Good, that's very nice. Now, if you guys have written it and you have no problems, then I will move to the next one. And this question, which starts from here, it says that the planet Jupiter and one of its moons, Io, may be considered to be uniform spheres that are isolated in space. Fine. So Jupiter has a radius r. Okay, so it means that the Jupiter itself has a radius r. And then it says that the mean density of Jupiter is rho. Fine. Io has a mass m and is in a circular orbit. So I read this. It means that it is related to Kepler's law about Jupiter with radius nr. So it is basically n times the radius away from the center of Jupiter. And you can also see that from the drawing. Now, this derivation is one of the most common ones, and it troubles the students the most. So I just want to, break it out. And trust me, it's not that hard. Okay, now let's do this. First of all, again, the moment I see it's in circular orbit and there's T and there's R, I should just focus that it is going to be related to centripetal force equals to gravitational force. All right, so this should be the first thing that should come in my mind. Now, centripetal force is given by m. Did they say, okay, the mass of the IO is small m, I believe. Where is it? Where is it? Let me see. Somewhere I read it. Okay, it's here. So small m, and the radius from radius is n r, and this is omega squared. Do you guys understand this? So the orbit's radius is nr. That's why I put. Okay, let me write the full form. Mr omega squared equals to gmm over r squared. Now I'll put it. So m is the mass of IO. The radius of the orbit is n capital R and omega squared. Everybody understands this? Should I go forward?
Yes, sir.
Then gm, m is the mass of Jupiter, small m is Io, and this is going to be nr whole square. Got it? Now, m and m irrelevant. They're going to get cancelled out, which means that then I get nr squared multiplied by nr is going to be nr cube omega square equals to gm. That's where I get. Okay. Now, from this point onwards, I'm going to look at something very, very interesting. Okay. If you really look at the question, you see till this point, I have m that I need to somehow remove from this equation. Also, I need to remove this from the equation. Also, I need to remove this from the equation. Do you guys understand this? So I'm just, thinking that how will I go forward from here? So then I'm going to say, fine, not a big deal. First of all, I'm going to remove omega, which is the easiest thing to do. So it's going to be n cube r cube. Omega is going to be 2 pi over t whole squared and gm. This will then be equal to 4 pi squared t squared equals to gm. Okay, now I got pi and I don't have 3, so I need to bring 3 somehow. From this point onwards, if you look at the equation, so I'm just going to put a slider here. Oh my goodness, I don't know what is the issue with this. I'll do it manually. Okay. If you see, there is density in this. And I have learned from my AS and my O levels and my IGs that density is given by mass over volume. Okay. If I need to bring density, I need to divide mass over volume. Also, if we consider they are basically spherical, which means, because they say they're uniform spheres, which means that the volume of sphere is given by 4 by 3 pi, and the radius would be r cube. What do you guys say? Understood? So basically, we're looking at Jupiter, right? So Jupiter radius is this, r, and we want to find the density. Can I say that the density can be written as m over 4 by 3 pi r cubed? Would you mind? Is it
No,
clear?
it's correct, sir. It's correct.
Can I then say that 4 by 3 pi times density is equal to m over r cubed? Okay, so let's keep it as our first equation here. Now, on to my previous equation. So what I remember that I needed to remove M and R from this, and that's right here. So if I could make this equation as subject, so can I write it as n cubed times 4 pi square over g t square equals to m over r cubed. That's the second equation. I basically made m over r cubed as a subject. Can I do that? Now, time to equate both of them. If I equate them, then it's going to be n cubed times 4 pi squared over g t squared equals to 4 over 3 pi rho. And now, everybody, you have 4 on both sides. So we're going to cancel 4 out. And then we have to make pt squared equal, rho t squared equal. So let's do that. So rho and t squared gets multiplied over there. And what do we have? And pi square also cancel out. So what do you get? N 3 times n cubed times pi. And then we can simply divide it by g. And that's when it is proved. Understood?
Sir, did you just miss an M somewhere?
What did I miss?
Like, you missed an M somewhere. You put M over R cubed, and then when you move to the next one, you missed an M somewhere. Where did the G and the M go together? Where
Yeah.
wasn't G and M together?
No, again. You actually got confused from this point. Let me erase this and then come back to this. Don't worry. This one is a difficult one, I know. So it's all right. Okay, let's see this. You do understand what I've done with the density, right? Here.
That part I do get, yes.
Okay.
I do get that part.
If I ask you to make this equation that you see, right? Sorry. If I say I want you to make m over r cubed the subject of this equation, how would you do that? You would take g on the other side and r cube on the right side, right?
Yes, yeah.
So if I want to write this equation as n, I'll do step by step, don't worry. R cube 4 pi square over t square times g. Can I do that?
Yeah. Yes, yeah.
And if I want to take r on that side, so then can I write it as n cubed times 4 pi
Divided
square,
by R square. R cubed.
right? It will be
I'm
divided,
just gonna
right?
divide. Yes, exactly.
If you look at this section and this section, don't you think they are the same things?
Oh, okay, I got it. Yeah.
So then when you put it back, right? So it's gonna be n cubed times 4 pi square over t squared g equals to 4 over 3 pi. Then check this out.
Yeah.
Check this out. You can cancel 4 with 4. You can cancel 1 pi with 1 pi, right?
Yeah.
And what do you need? You need p t square as the subject. So can I multiply this t right here?
And then you leave the G under the fraction, yeah, denominator.
Yeah. So if I do that, and 3 will go there. So can I write it as 3 times n cubed times pi? That's left on the top, right? Divided by g equals to pt square. Now check what they have given. 3 pi n cube over g equals to pt square. So this is proved. Do you understand?
Yeah.
Okay. This one is the hardest one that you may come across, but these are the only 3 that they will ever give you. So, and this comes so many times, you'll see repeatedly, like you see every once or the other year they give the same question. Like you see from 2009, I took a question And then in 2013, there was a question. 2017, there's a question. Do you see the pattern here? And I intentionally left some of them because they were repeated questions. So the thing is that only these three questions will be there when it comes to derivation of Kepler's law, or the use of Kepler's law in the broader sense. Okay.
So why did they make this so complicated?
To give you 4 marks, Gatika.
So it's less compared to the amount of hard work.
Yes, it is 4-mark question.
I totally
Like-
agree, sir.
Yeah. So always remember you're in A levels now. Do not forget that fact. All right. Now,
Unfortunately.
but the thing is, you can get away with anything in A levels if you remember the very first concept, and that is whenever there is going to be a Kepler's law, relationship, you remember the centripetal force is equal to gravitational force. That's the clue. Understood?
Sir,
Yes,
why didn't they
sir.
give us less space compared to what we need? I think we need an entire page for this thing alone.
No. The questions that I copied, okay, I made them smaller so that it could fit the space. Otherwise, the pages were too long. This worksheet that I've made is 60 pages,
Right.
If I had not reduced the size, it would have been much more than that. Understood? So that's why in the actual paper, there will be a lot of space. So don't worry about that. Okay.
Yeah, you better give me an entire page for this one.
Yeah, but it's all right. It's okay. You guys can do it. I know. All right. Now, so when you're doing these type of questions, which I have given you, further in this worksheet, just remember that if you get stuck anywhere, you can always rewatch the recording how I have, gone from one point to another, and it will help you, manage it. It's not a big deal. All right. So once you try this, it will be fine. So whatever. And now let's go to the geostationary satellites. Now for geostationary satellites, the only question that can ever come is the 4 properties of geostationary satellites. But we should also know what these are. So this is not required, but just to tell you what geostationary means. So geostationary satellites are the ones that appear stationary with respect to a fixed point at equator. So if you're standing at equator and looking at it, it will always stay at the same point. The reason why it stays at the same point because of these 4 properties that you need to remember. First of all, the geostationary satellite has the same angular speed omega and the period t time period as Earth. The other thing is that it has the same direction of travel as Earth. Third thing is that it only has to be on the equatorial plane, which means it has to be on the equator. The fourth point is that it is always at a fixed distance above the Earth's surface. So you got to remember that. Okay, so please write this down. These are 4 important points. The only thing they can do is they can give you 2 of these and ask 2 of them. So please do remember all of them. They can give you any 2 and ask any 2. So yeah, unfortunately. Okay. If you guys have any question, Nadia, Suman, why are you late? Please tell me this. Okay, and Munib, everything is clear. Moktesh and Musa, Nadia,
Yes.
otherwise Anusha, Fahar.
Yes, sir.
Good. Good. All right. Anytime you want to learn this in detail, you can always go to the YouTube channel. You can always, look up for the detailed lectures. But right now, we're only targeted with respect to questions. So that's up to you. Anyway, now going to the binary stars. Now, recently, I've noticed that binary stars questions are very common. Now, what are binary stars? Binary stars are like, suppose you have one star, all right, and then another star, which have a common center. And obviously, from that common center, they have their own distances. So let's suppose R1, and this star has R2 distance. And they basically go about in the same direction with each other, like clockwise or anti-clockwise, about their same common centers, and they may have different masses as well. So this point is the common center, right? Now, again, for binary stars, we need to remember 4 properties. Okay. Now, probably they will never ask you about the properties, but remembering this will help you solve the questions. Okay. So binary stars are a set of 2 stars that are relatively close to each other, that orbit a common center. The other thing is that this is the most important thing, the second most, in fact. They have the same time period and angular speed omega. So let me just move this away right here and move this here. All right. So they have the same angular speed and time period. This is very, very important for you to know. The third point that you should remember is that the centripetal force is required for their individual circular motion, which is obviously provided by gravitational force of attraction between them. Now, the fourth point is the most important. So I'm putting 2 stars on this, okay? And you should always remember this. This will help you in a lot of questions. So the thing is, let's say the distance between the masses and their centers, and the centers of the stars is in inverse ratio of their masses itself. Now, what it means is that suppose if you take a ratio of mass of the first star over mass of the second star, then the ratio is inverse, which means the radius of the other star from the common center over the radius of first star. So they are basically inversely proportional like this. Is that clear, everyone? Right. Please have a look at it. Let me know if you have a question here. All right. Now, speaking of the question now, so this is a typical binary star question. Okay. I'm sorry. Can you write it down?
So can we consider planets as binary stars?
No, because the main difference between binary stars and two planets orbiting a common sun, okay, or star is that the planets have different time period and angular speed. Do you understand, Gatika?
Yes, sir.
The first condition for a binary star to exist is that both of the stars must have the same time period and same angular speed.
Okay.
Which can never happen with planets because obviously planets are rotating a central body, and in this one there is no central body, there's just a common center. Do you understand the difference now?
Yes, sir.
Good, very nice. Okay.
I have a question.
Yes, Anusha, go ahead.
So point 4, does it mean that if the mass is greater, the distance between the center would be less?
Obviously, that is correct.
Yeah,
100%.
okay.
It's inverse proportion to that. That's very nice, very nice. Now, let's go to the question, okay? All right. I need some air. Okay. All right. So, okay, very nice, very nice. We're just starting. So, in the next question, if you see, it says a binary star consists of two stars, A and B, and obviously, that says that stars A and B orbit each other, as you can see, and obviously, they say the star in orbit centers, and the center of them is P. Just by looking at it, just by looking at the distance, D, can you tell me which star has a greater mass? Just by looking at it, doing nothing really.
Star A.
Star A has the greater mass. Why?
It's got a bigger radius.
It's no. Okay.
So isn't it star B?
No. It has
So
to
it's
be.
star A because it is bigger in size.
No, it looks bigger, but even if it was not like that, but then you should remember the center, that the common center is closer to A, which means that it has a greater mass. That's what Anusha asked me just now. Do you understand?
So could you repeat that?
If the center is closer to this one, right, Gatika? This just for
Yeah.
you, which means obviously inverse ratio means the star which has a greater mass will have a smaller distance from common center.
Okay.
Do you understand now?
Yes, sir.
Okay, very good. Now, so coming to this question, very important. It says, explain why centripetal force acting on both stars has the same magnitude. Now, this is actually not related to gravitational field. It is related to something else. Can you please tell me why the both stars will have the same force? Yes.
Newton's third law, maybe?
Very good. It is the correct answer because The only reason why they will have the same forces between them is because they are being attracted by, first of all, law of gravitation, right? So you can say gravitational force, right? This will give you 1 mark. Now, the other point is that the force is equal and opposite due to Newton's third law. Do you guys understand this? Please do not forget AS. All right. So if
So
two
what's
forces,
the fourth word?
what's the fourth word?
Oh,
They are
attracted. Okay, attracted.
they are being attracted by law of gravitation, gravitational force, and the force is equal and opposite due to Newton's third law. All right. Okay. Now, in the next question, it says the period of the orbit of star is about p is 4 years. Calculate the angular speed. So we're going to do 2 pi by t, and you see it's in seconds. So we're going to change 4 years. So it's going to be 2 pi. 4 has 365 days, and 365 days has 24 hours, and each hour has 60 minutes and 60 seconds. That's how you change it, right? I believe. Okay. Now, you take out the calculator, try and do this. So if I make a mistake, please, everybody try to solve this. Please let me know if I make a mistake. 60 times 60. So this is about 1, 2, 3, 4, 5, 6, 7, 8. This calculator sucks. Okay, 4.98 times 10 raised to power minus 8 radians per second. All right. So you can write it like this. Okay.
So can we round off to 5.0?
Yes, you can also do 5.0, but do not write just 5 because then it will be wrong because it does not conform to the significant rules. Okay. Now, those who do not know this, it's a good thing that you asked. This is from AS, but I just want to tell you that the answer that you always give must be in minimum significant figures in data or one more than that. Like, for example, in this question, it is 2 significant figure in data, right? So your answer should either be 5.0 times 10 raised to minus 8, or it could be one more than that, which is 4.98. Do you understand this? So significant rules are very important. Please follow that. Now, going on to the next one. This says that the separation of centers of the star is 2.8 kilometers, 2.8 times 10 raised, right? The mass of star A is MA, the mass of star is MB, and the ratio. Determine the distance D. Now think about this, please. If this is D, then can I say this distance is 2.8 times 10 raised to power 8 minus D? Can I do that, please?
Yes.
Okay, so according to this, then, if this is radius of A and this is radius of B, do you know the relationship I told you before? What was that in the fourth point?
M1 over M2.
Okay, can I say MA over MB is RB over RA? Because
RA.
they're inverse ratio, right? Can I say this, please? Now,
Yeah.
it would be very difficult for you if you do not remember this point. That's why I put 2 stars on it. Okay. Now, this whole thing is 3. RB was basically 2.8 times 10 raised to 8 minus D, and RA was just D. You can go back and check. Is it clear, everyone?
Yes, sir.
Now, if you do not remember, again, if you do not remember this relationship, you are in trouble, my friends. So you have to remember this. Anyway, then it's 3d equals to 2.8 times 10 raised to 8 minus d. You take it there, it's going to be 2d. Oh, no, sorry. It's going to be 4d, 3d plus d. 2.8 times 10 raised to 8, and then you can just divide it. See how easy is 3-mark question? You were complaining about the 4 marks? Gatika, what do you say now?
So this 3 marks is fine. That one, we need more than 4
No,
marks.
this is not fine. This is basically unfair, Katika. So if they are giving you a harder question at some point, they're also giving you answers for like easier questions for
So in
the other.
exam, we get only one question, not multiple choice.
Still, you should remember that it will be pretty balanced. Don't worry about it. So 7.0 times 10 raised to 7 is this. Again, I'm reiterating this. Why I have written 7.0? Because the minimum significant figures, as you can see, are 2. So that's why I've written in 2. Okay. Now it says, use your answers in A2 and B1. Where's A2? Okay. Omega. To determine mass MB of star B, explain your working. Fine. So it means you have to provide the working, otherwise they were not going to mark this. One of the ways that you can actually do this is by applying the centripetal force equals to the law of gravitation. So it will be, you can write it as mr omega squared. You can take one of those, right? And then obviously you will be able to find easily. So can I say this is, if I'm talking about MA and the radius would be RA in this case, right? RA was what? RA was D. So can I say this is 7.0 times 10 raised to power 7, right? But the issue is that this is in kilometers. I just realized. So you have to change it into meters. So if I change it to meter, it's going to be 10, right? Okay. Times omega was 4.98, I remember, something, times 10 raised to power minus 8. Okay. Then whole squared equals to, this is 6.67 times 10 raised to power minus 11. The mass, this mass, obviously one is MA and the other is MB, and then divided by the distance between them was 2.8 times 10 raised to power 8 kilometers. So I got to change this to meters, which makes it 10 raised to 11 whole square in meters. Now we got to solve this. So naturally, the reason I chose MA on this side, because I want to find MB. So this will automatically cancel out. That's great. And now I can just simply find MB using my calculator. Let's do this. So what I'm going to do is 7.0 times 10 raised to power 10. And then it's being multiplied by 4.98 times 10 raised to power minus 8 and whole square. Okay. Anything else multiplies? Yes, there is one. Uh-oh. I got to go back. Back. Okay, multiply by 2.8 times 10 raised to power 11 whole squared, and then I got divided by the gravitation constant minus 11. So this seems to be, wow, huge. Let me check what that might be. It is basically MB comes out to be 2.04 times 10 raised to power 29 kilograms. So you can just get away with 2.0 times 10 raised to power 24 kilograms. Is that clear, everyone?
So 29.
Oh, sorry. My bad. Thank you, Katika. And this would be 29. Okay. All right. Juveria, is that clear? Munib, Suman, Tanjim, Ahmed.
Yes, sir.
I'm still typing. Give me a second.
Okay. All right. Fahar, is it clear? Abdul Moiz, Musa, Nadia,
Yes, sir.
Mokshit, do you understand this?
Yes, sir.
Very
Yes,
good.
sir.
Excellent. So if you just remember that relationship, no binary question, no binary star question will be difficult ever. So that's what you should do. Sir Numan is so angry at me because I take his class every day. Doesn't like it too. So we're going to stop here today. And probably we are going to complete this chapter tomorrow. And by Friday, you have to submit the worksheet by completed date. Okay. So I'm going to see you again, same time. Have a nice day. If you know more questions, if you have questions, please do ask.